So in this video, we're going to talk about topics 8.7 and 8.8. They kind of go together, so we're going to kind of just do them all in one shot together. So this is the volumes of cross sections of squares and rectangles and triangles and semicircles. So our essential question is, how do you find the volume of a cross section? And your I can statement is, I can calculate the volume of a known cross section using definite integrals. So our focus is going to shift from using the definite integral to find the areas of two-dimensional shapes to finding volumes of three-dimensional shapes. Our first technique, however, will rely on using simple two-dimensional shapes and stacking several of them together to form a three-dimensional figure. So, what we're going to do is basically when we think about taking the integral of area, that gets us volume. So this is kind of how I think about this. You've got your position, your velocity, and your acceleration, right? As we go down this list, we know we take the derivative. As we go up the list, we know we integrate. So I also think about this as volume, area, perimeter. Okay, as we go down the list, we take the derivative. As we go up the list, we integrate. So if I have the area formula to get volume, I'm going to integrate it. So volume is kind of like position, area is kind of like velocity. So basically, I take the area and I integrate it. And then sometimes we're perpendicular to the y-axis. That would just mean we do this in terms of y. So if you want to see what an example of this looks like, this building is in Kansas City. And fittingly enough, this is actually when they're in person grading the AP Calculus exams, this is actually the building they calculate there, that they actually grade them in. So it's kind of cool looking building. And you'll see that it's making it looks like some cross sections of maybe like a quarter circle. But you're adding up the areas of each one of these little shapes, and then that becomes the volume of the whole thing. So the calculus exam is going to focus on four main shapes: a square, a rectangle, a semicircle, and maybe several varieties of triangles. We're going to complete the table below to provide the required information, for example, the attributes of the figure that are used to find the area and the area formula. So a square, you basically need the length of the side. So our area formula would be side squared. The rectangle, you need the length and the width of two sides. So the length of a side, the width of a side. So area equals length times width, or base times height, just depends on how you learned it. A semicircle, you need a radius. And we know, and it's typically a semicircle, not a full circle. So the area of a circle is pi r squared, and a semicircle would take half of that. If they ask for a quarter circle, you'd take a quarter of it. And then a triangle is the length of the base times the height. Base and height is what you need. And then the area is 1/2 the base times the height. It's kind of a hint for later on. You'll notice that at the end of these notes, if you go beyond where the summary is, there is actually a sheet that kind of puts all these formulas in the context of calculus. And they talk about an equilateral triangle, an isosceles right triangle. So there's some extra triangle formulas in there that you might need when we're doing these. I'm not going to go through how they are developed. I'm sure you could do a YouTube search and figure out how they're developed, but that's not the best interest of our time. We're just going to use the formula.